Hello everybody. Today we are going to take a look at Leetcode question 2342, max sum of a pair with equal sum of digits. So we are given a zero indexed array nums consisting of positive integers. We have to choose two indices I and j such that I is not equal to j and the sum of digits at the index I is equal to the number is equal to the sum of digits the number present at index j. We have to return the maximum possible sum we can obtain by choosing I and j indices. Right. So let's look at an example. 18, 43, 36, 13, and 7. Okay. 18, 43, 36, 17, 7. Right. So we can pick up any indices. So let's say we pick up index I to be this and index j to be this. Now we have to make sure that the sum of the digits is equal in both these places. So 4 plus 3 is 7 and 7 is also 7. So the index match, which means we can take the sum of these two numbers. 43 plus 7, the maximum possible is 50, right? But if you take a look at the other pair of numbers, like for example 18 and 36, now the sum of 1 plus 8 is equal to 3 plus 6, and we can pick these two numbers and the total sum will be 54, which is greater than 50. So this will be our answer. And if we take a look, there does not exist any other combination which can give us a sum greater than 54. So this is what we have to return. And in case if there are no numbers possible, no choices possible, we have to return -1. So the brute force approach we can think of is so we can loop through the array and we can have a loop going for each index I, and we can have an inner loop that goes through each index j, and we try to see if there exists a match, and if they match we can calculate the sum and store the sum, right? uh, that will be a brute force approach. The time complexity for that will be of n square, right? Of n square. uh, if we take a look at these if we take a look at If you take a look at the sum, that is the only condition that we have to make sure, right? So we can pre-calculate the sum of digits for each of these indexes and store them in some sort of a data structure, and then use these to find the I and j values possible. So for example, let's calculate the sum of this to the sum of all the digits. So we can calculate the sum of the first element to be 9, then this is 7, then this is 9 again, this is 8, this is 7. Now if you see, we have to combine all these nines together so that we come to know the maximum sum possible. So we can use some sort of a hash map for this. So we can store the sum, the digit sum as the key, and then the value will be the elements that have this digit sum, right? So for example, we can have 9 as the digit sum, and the digit sum 9 is possible with the numbers 18 and 36. So we can store numbers in this format for each digit sum possible. And once we have this list, we can pick the top two elements, the highest two elements, and that will give us the maximum possible sum for that digit, right? Right. So again, if we take a look at this, we can either sort this list, right? The value, whatever we have, we can either sort this, but if we sort this, then again, it will take some time for that. Or we can either loop through the array, like we can pass through the array two times to calculate the highest and the second highest possible numbers. That is also possible. Or we can use a heap to store the maximum numbers possible, and then we can get the top of the heap in constant time, right? So I'll implement using a heap. The other solution will be fairly simple. Right. Let's get started with the solution. So we have to first create a hash map. Let's call it digit sum. I'll use a default dict for this so that I do not have to make the key, checking the key for each digit, sum of the digits. Right. Now I'll loop through the numbers. So for each number in nums, I have to calculate the digits. So I'll calculate the digit with a helper function, right? Digit sum self dot sum n. So let's write this function first. So we have a function called sum, which takes a number n and which returns a total sum of those digits. So I'll have a while loop that runs till the number n is greater than 0. I'll calculate the total. I'll add the digit in the ones place total, and then I'll divide the number by 10. This will give me the sum of all the sum of the digits of this number n. And once I have this, I will just uh, add this to my digit sum hash map. So digit sum, sum, and because I'll be using a heap, I can do push the number instead of appending to the heap. And because I need to store the maximum number possible, I'll just negate it. So I'll have the max heap. So once this is done for all the numbers, I'll loop through the hash map again. So for key, comma, value in digit sum dot items, and we have to only check for this value. We have to just we have to check for the maximum sum possible only when the length of the hash map, the heap, is more than 2, because we need 2 values, right? So we can put that check here. If length of v is greater than or equal to 2, when we find out the total, that will be heap q dot heap pop v, then heap plus heap q dot heap pop v. Because we have pushed the number in the negative, we'll just negate it here as well, so that we again get the positive numbers back. And once we have the total, we also need to keep a track of the maximum sum possible, and we have to return -1 if there is no if we do not have any ij values possible. So I'll just instantiate a max sum variable that is equal to -1 initially, and max sum will be max of max sum and the total. Once everything is done, we can return max sum, right? So I have a hash map defined here. For each number, I calculate the digit sum. I push it into the heap with a negative sign so that the maximum number is stored at the top. Then for each of the keys and values in the hash map, if the length is more than 2, I take out the total. I find the total by popping the top of the element twice. And once I pop the element twice, I can calculate and compute whether if it is greater than my max sum and store it in that variable. And in the end, I return that. Okay, let's submit. Let's run the test cases first. Okay, test cases are passing. Let's submit. Okay, accepted. Thank you.